Okay, and welcome back to Math for Business and Finance and Math Application students. Chapter 3, Drill Problems, the odd number problems. And in our last video, we finished up on 3-41, I believe. So let's pick up with 3-43. And let me get a pen here. Okay, it says, divide the following and round to the nearest hundredth. Okay, but before I get started, notice that this here is 29,432 divided by 0.0012. Okay, now before I get started, I'm just going to bring up a concept, an idea, theory, and let you see it. Get a blue pen here. I want you to understand the theory or the idea behind this, but I'm going to use a different example. Let's say I have 6, right? And we all know that if I divide a number by 1, you're going to get that number. So 6 divided by 1 is 6. Okay. Now, if I have a 1, okay, and that's right here, if I go up or I go down, in other words, if I divide by a number greater than 1, I'm going in this direction, and if I divide by a number less than 1, in other words, a fraction, okay, I'm going this way. But you'll see what I mean in just a second here. I just want you to get an idea here. All right, so if I have 6 divided by 1, I have 6. But when I divide 6 divided by 2, now notice I'm using a greater number, okay? When I'm dividing by 2, I end up with 3. That means my answer is going to be smaller than what I'm dividing into, okay? So it's a smaller portion. The same as if I go and I take 6 and divide by 3, that's an even greater number, which means my answer is going to be even smaller and ends up being 2. Okay, and I can just keep on going with this. Okay, if I take 6 and I divide by 6, I end up with 1. Okay, so again, the greater the number, all right, the smaller my answer is going to be. All right. When I'm dividing by the number itself, I get 1. If I divide by a number that's greater than that number, now I'm going to end up with fractions or decimal places. Right? But the point I want to make out here is that just common sense says if I divide by a number larger than 1, my answer is going to be less than the number I'm dividing into. Okay, right? I'm using 6. If I divide by a number greater than 1, my answer is going to be less than the number I'm dividing into, which is 6. Right? Conversely, if I'm dividing by a number less than 1, right, divided by 0.5, let's say for a half here, then that means my answer is going to be greater than the number I'm dividing into. I mean, let's take a look at it. 6 divided by 0.5. Okay, so I have to move the decimal one place. Okay, right. So 5 into 6 goes one time. That's 5. One remainder. Bring down the 0. That's 10. 5 can go into 10 2 times. That's 10. 0 remainder. So my answer ends up being 12. Notice that when I'm using a number less than 1, okay, my answer is going to be greater than that 12. I mean, think about it. 12 times 0.5, all right, ends up being 6. Okay, but so the point I'm getting at here is that when I'm taking this here whole number and I'm dividing by a number that is less than 1, my answer should be greater than that number. Okay, if I'm dividing by a number that's greater than 1, my answer should be less than that number. Okay, all right, so with that said, let me erase all of this here. Go back over this if you didn't understand that. Do try some numbers yourself to see what I'm talking about. But okay, so let's go and let's do this here math. So if I take 29,432 and I'm dividing by a number less than 1, I'm expecting my answer to be greater than 29,432. Now it's telling me that I need to round to the nearest hundredth, right? And since here's my decimal place, okay, I have to move the decimal place 1, 2, 3, 4 to begin with. So 1, 2, 3, 4. It's going to be 1, 2, 3, 4. So here's my decimal place. And it's telling me to round to the nearest hundredth, so I have to add 3 more zeros after that. Okay. So notice how large this number is automatically beginning to become, right? We're talking into the millions here, right? So let's do the math, and don't mind my scribbling here because I'm going to run out of space. But 12 into 29 goes 2 times, that's 24. Bring down a 5, 54. 12 into 54 goes 4 times, that's 48. Bring down a 6, carry my 3, 12 into 63 goes 5 times, that's 60. Bring down remainder of 3, bring down my 2. 12 into 32 goes 2 times, it's 24. Remainder of 8, bring down my 0. 12 into 80 goes 6 times, that's 72. Remainder of 8. Now, I don't have to keep on going, right? Because when I know that 6 times 12 is 72 and I have a remainder of 8, I'm always going to be bringing down zeros, so I'm just going to have a repeating pattern here. So I don't need to do the rest of the math. All I need to do is just write in all of the 6's. Just keep on going, because this is going to go out to infinity. This is a repeating number now. And remember, I had said earlier in one of the very first videos that to show a repeating number, all I need to do is put a bar over the top. What that means is that that number is going to just keep, that series of numbers. In this case here, it's just a 6. That 6 is just going to keep repeating out to infinity. As a quick aside, if I had, say, 0.632 and the answer was going to keep on repeating the 32, I'd put the bar over the 32. And what that would look like would be 32, 32, 32, and that's what the number would look like. But we don't want to just keep writing out, forever. So we just take those repeating numbers and we just draw the bar over that repeating number, and that represents that number being repeated out to infinity. So with that said, up here, here's my repeating number as a 6, and I want to round to the nearest hundredth place. So that ends up, here's my hundredth place, and I look to the right, and that's a 6, and that's greater than 5, so I'm going to round that digit to a 7. So my answer ends up being 24, 5, 26, 666.67. Okay, so I end up with 24,526,666 and 67 cents. Okay, so that's the answer. Now, I look in the textbook and I see that the textbook shows the answer being 24,526.67. Okay, so obviously that's wrong. Okay, so there is an error in the textbook. What it looks like to me is that when the author, it could have just been a misprint in the publishing of it, okay, a typo error, but it looks like to me that the author may not have been dividing by 0.0012, okay. He might have, it looks like he just started out by dividing by 12. But then, remember, if the number is greater than 1, that means your answer is going to be less than what you're dividing into. Okay, so like I said, it appears to me he either divided by 1.2 or by 12. I'm not going to do the math. I really don't care. But that's what it would have to actually be 12. No, 1.2 could be. All right, maybe he did 1.2. And that would have ended up giving him that answer there. Okay, but he certainly didn't divide by 0.0012. So just be aware that that is a mathematical, typo error in the textbook. Okay. and take it for what it is. Right? That problem took me 10 minutes, so I'm going to stop and pick up in the next one.